Hello everyone, welcome back to our channel. In this video, we are going to discuss about the important questions for the examination 21 Easy 51 Computer Organization and ARM Microcontroller, Module 1. Come, let's go into the video. Module 1, first question. Explain interrupt and interrupt hardware with steps enabling and disabling the interrupts. So we have to first explain what is interrupt. So for better understanding, you can explain what is interrupt hardware. So here you can start explaining that the interrupts will be disabled on starting the ARM CPU. So first, unless it is switched on or it is initialized, all the interrupts will be completely disabled. So this can be enabled or disabled using the CPSR or the processor status register PSR bit. Using that bit, it can be enabled or disabled. So this circuit diagram can be drawn to ensure that with this INTR 1, 2, so this will be either closed or opened to ensure the enabling and disabling of the interrupts. And there are two general purpose interrupts that has been used, that is interrupt request and fast interrupt request. So these are the general purpose requests that has been used to enable and disable the interrupt. So you can explain interrupt, what is interrupt hardware, with these steps how you will enable and disable the interrupt with this diagram. Moving on to the next question, difference between memory mapped IO and IO mapped IO. So here you can see memory mapped and IO mapped. Yes, so here memory mapped is nothing but this is a method where the input and output functions will be between the CPU and the peripheral input output devices. Yes, so here you can see that the complete method will be performed, that is the input output operations will be done between the CPU and the peripheral devices, but there will be a space that is between the memory and the input devices. Here the memory mapped will be using the same address space for both the memory and the input output device. Here separate space will be used for memory and IO devices. So like that you will be explaining some 6 to 7 inputs for memory mapped and IO mapped input. And then moving on to the next question, examine the features of USB tree structure with split bus operation. So this is the USB slits. You have a root hub which is subdivided into another hub, and those hubs are divided into input output devices, and the root hub will have a host computer. So to accommodate the large number of devices that can be added or removed at any time, the USB will have this tree structure. So here each node of the tree will be called as a hub, and each hub has an intermediate control point between the host and the input output devices. So you can explain this completely, why there is an intermediate node, what this input output devices does connecting to the hub, all those can be explained. Third question, define addressing mode. Explain different types of addressing modes with example. So define addressing mode is nothing but it is a one which is been registered, or it has been taken to ensure that each and every bytes in a microcontroller or a microprocessor is being kept at the location. So addressing mode, you have different types of addressing mode: register to register, absolute, literal, indexed, pre-indexed, post-indexed, double register, index. So these are some of the addressing modes available: immediate addressing, direct addressing, indirect addressing. So with an example you can explain. So here the instruction has been given for register direct move R0 comma R1. So now you can create a table that register R0 with this address have this value, R1 with this address has some value. How the value from the R1 is moved to R0 can be determined with an example. Moving on to the next question, illustrate with neat diagram synchronous and asynchronous buses. So here synchronous and asynchronous buses, with the word only you know synchronous always syncs with the time, and asynchronous always doesn't sync with the time. So here all the devices, this is the timing information of synchronous and asynchronous. So here you can see with the clock period, for one clock period time we calculate how many bits has been transferred from one end to the other end. Here you can calculate, there is no time period, the time the clock is being switched on and the data is being keep on passing from T0 to T5. So you can explain like at T0 what happens, the master places, so the master line will be how the data will be transferred, or how the slave lines transfers the data. All those can be explained in detail. So that is nothing but with this diagram you can start explaining it. Explain logical shift operation with example. So logical shift operation, here you can see LSL, logical shift left, logical shift right, arithmetic shift right, rotate, logical rotate. This is logical rotate. So how it has been happened with this block you can explain, and here you can see arithmetic shift. That is, see, you have the bits. This is before shifting 10011 till 010. Okay. So here after shifting what happens? Left shift. Okay, so now what happens is this one is taken this side and this 0 will be moved this side. So this is how you have to perform the logical left shift. So first you can explain this and take an example and start explaining how it has been logical shift is performed, logical shift left and right has been performed. So hope you have understood the small tips and the important question for the module 1. Please be stay tuned for more information. Thank you for watching. All the best for your exam.